Hello. Hello. Good morning. Good afternoon, guys.
Good afternoon, sir.
So, should we start now? Are you settled with your pencil and drawing sheet? Roll number 6, Suraj. Are you there?
Yes, sir. Yes, sir.
You please send me the contact number.
So I filled out form, no?
Okay.
One form was there.
15 has failed. 6. Failed. Roll number 9. Roll number 9, Kamle. Are you there? Roll number 9. I think he is not there. Roll number 9.
Yes, sir.
Okay. So you please provide me the contact details of your parents.
Yes, sir.
Okay. I have also messaged you on WhatsApp. So you can give the number of parents or the guardians in case parents are absent, parents are not there, then guardians you have to give the roll number of. Okay.
Yes, sir.
Yes. So now let us start with our next topic, that is the acceleration analysis in the mechanism. Okay. So is it visible the screen?
Yes, sir.
Okay. So acceleration, all you already know what is it, how you define it. that it is the rate of change of velocity, okay, is known as acceleration. And to find out the few forces, you also make use of the acceleration, like force is equal to m into a according to Newton's second law of motion. Then you also calculate the weight equal to m into g. G is what? G is the acceleration due to gravity. Okay, so in mechanism, acceleration analysis is also important in order to understand the forces and their magnitudes which are acting on the different parts of the mechanism. Okay, so only this thing you need to remember, that when a point moves in a circular path, okay, it will have two components of acceleration. And which are those components? That is your centripetal acceleration, okay, and tangential acceleration. Okay, so a particle which is moving in circular path, say acceleration its acceleration consists of two components. One is centripetal component. We denote it by the superscript c, ac. It is the centripetal acceleration plus the tangential acceleration. Okay, ac, at. You add these two components vectorially. Okay, these two are vector because acceleration is having magnitude as well as direction. Okay, so vectors are added in different fashion by different method. Remember, it is not the algebraic sum. So let us see what is the centripetal acceleration. What is the formula for it? That is the what is the particle velocity v square upon r. R is the radius of the point. Okay, so radius is what? Radius is the distance of the point from the center of rotation. Okay, so you are now knowing the magnitude of this centripetal acceleration. And what about the direction? Its direction is parallel to the radius towards the center of rotation. So this component, centripetal acceleration, will act towards the center. Okay, so for example, a particle is moving like this in this circular path. Okay, so what will be the direction of centripetal acceleration? It will be, say, here is the center of this curvature, and say your particle is here. So the direction of centripetal acceleration will be along the radius. This will be the direction, and whether uh, towards the center of rotation or away from the center of rotation. So as it is centripetal acceleration, it is towards the center of rotation. It is the direction of centripetal acceleration. What about the tangential acceleration? Tangential acceleration acts perpendicular to the radius. Okay, so it is your radius, say r. So perpendicular to radius means it will act like this. Okay, this is the direction. This is the direction of the tangential component of acceleration, like this. So centripetal acceleration will act along the radius, and tangential component will act perpendicular to radius. In this way, you can say that centripetal acceleration is perpendicular to tangential acceleration. Okay, and when you add these two components, then you get the total acceleration of the point. Total acceleration of the point. Understood it? Did you see the formula how to find out the centripetal acceleration? V square upon r. Tangential acceleration, how you will find? Its formula is equal to r into alpha, where alpha is what? Alpha is the angular acceleration of the particle or of the link on which particle is present. Getting this?
Yes, sir.
Okay. So acceleration, vector of acceleration will have two components. Okay. And how to know the magnitude and direction, I explained you in this slide. So you note it down, this particular formula, then we will see the further analysis. In order to draw a vector, you should know both, that is magnitude as well as direction. Then you can show the vector with the help of a line in particular direction. Let me know if you are done with noting it down.
Done, sir.
Okay, so let us then go to the next slide. Okay, now here let us draw the acceleration diagram for a link. Okay, so this link is represented by 2 points on that. Okay, so point A and point B define the link, means it is a link A B. Okay, so we have already seen that when the links move in the mechanism, one point acts as a center for the motion of the another point. Okay, if these 2 points are on same link. Okay, so let us say that I want to find out the acceleration of point B with respect to point A. Okay, so I will write down acceleration of point B, okay, with respect to point A. Okay, I know already that this acceleration will have two components. Okay, because point B is rotating with respect to point A. Point A is center for point B. Okay, so I know that this acceleration will have two components. What are those? First one is the centripetal component, which is also known as radial component, which is also known as radial component. Okay, so indicate it like C here or R. Why it is called as radial component? Because this component acts along the radius. Okay. So second component will be the tangential component. Tangential component of B with respect to point A. This is my equation. Okay. Now let us look at the label, how we can label this particular acceleration. Okay, so acceleration is the vector. Now you tell me what will be the name of acceleration of B with respect to A. क्या लेबल होगा इसको, ये जो वेक्टर बनेगा एक्सेलरेशन ऑफ बी विथ रिस्पेक्ट टू ए, उसका लेबल क्या बनेगा?
VBA.
यस,
VBA.
AB, correct. I told you in last practical how to write the name of the vector. So name of the vector will be what? AB. AB. This vector will start from point A and will end at point B. But if you remember, we are using the small letters in case of velocity vector. So let us give some different name for acceleration in order to distinguish the velocity and acceleration. So as we are using small letters for velocity, for acceleration we will use the small letters with dash. Okay, so I will show this vector as a dash, b dash. Okay, so these letters with dash, they will indicate the acceleration. Okay, now this vector a dash b dash, it also have the two component, one is centripetal and one is tangential. So the centripetal component, this component will start with the point a dash. Okay, say centripetal component will start with point a dash and it will finish, it will end at an intermediate point x, a dash x. Okay, then tangential component will start from x, it will start from point x, small x, like this, and the tangential component will end at b dash. Okay, so the label for tangential component will be x b dash, like this, a dash x, x b dash. If you add these two component a dash x and x b dash, then whatever resultant vector will be, that will be a dash b dash. Okay, so these are the components and it is the total acceleration. Remember this. Okay, so label you have decided how to do the labels. Okay, now about the magnitude, you already know how to find out the magnitude. What is this? It is the centripetal component of acceleration of b with respect to a. So formula for calculating the centripetal component is what? Is velocity ka square, right? Velocity ka square upon radius, v square upon r. So what is the radius for point B? Okay, for point B, A point is the center. So AB will be nothing but the radius for point B. So formula will become like this, v square upon r. R is the radius. So radius is nothing but AB. Using this relation, you can find out the centripetal acceleration. Again, which velocity you have to take? You have to take the velocity of B with respect to point A. That is, you have to take velocity of B with respect to A. This velocity either you can find with the help of a formula, or you can find it from the velocity polygon. Got it? It's uh, then by magnitude you are knowing this. Okay, so let us now draw this vector. It is centripetal component. From which point it is starting? From point A dash. Okay, so I will assume somewhere a point A dash. Suppose here is my reference point A dash. Here. Now I know the magnitude. So according to magnitude, I will set the scale. For example, if this value comes as 9000 mm per second square, then I will select the scale like say 100 mm per second square is equal to 1 mm. So this length will be 90 mm, right? So which vector I have to draw? I have to draw the A dash x. What is the direction of centripetal component? It will be along the radius. What is the radius AB? It is along this direction, parallel to the link, parallel to the link. Okay, but parallel to the link, whether you have to draw upward or you have to draw downward. Okay, so always remember that it is centripetal acceleration is acting towards the center of rotation. Okay, so center of rotation क्या है? Point A है. Point A है means this radial component or centripetal component will be acting towards point A, means downward. It will be acting downward. So I will draw a vector which is parallel to the link and which is coming downward like this. I will not draw it upward. A dash x. Are you getting the procedure? What I am doing?
Yes, sir.
Okay. So as you know that to draw the vector, you know magnitude. You need magnitude as well as direction. So magnitude, we know the formula for magnitude, and direction we know that it is towards the center. So for point B, point A is center, so it will be acting downward. So from A dash point I came downward, and this length will be proportional to this magnitude which I found. Okay, then after this I will draw the tangential component. Okay, so टेंजेंशियल कंपोनेंट कहाँ से स्टार्ट हो रहा है? पॉइंट एक्स से. एक्स पॉइंट से स्टार्ट हो रहा है मीन्स यहाँ से मुझे स्टार्ट करना है. दिस इज द पॉइंट एक्स एंड आई विल ड्रॉ दिस वेक्टर बी डैश. ओके, सो फर्स्ट आई विल नो व्हाट इज द मैग्नीट्यूड ऑफ दिस वेक्टर. कितना इसका मैग्नीट्यूड है? ओके, so for magnitude I know the formula that tangential component is equal to r into alpha, radius into angular acceleration. Okay, so radius is nothing but a distance AB, that is the actual distance between these 2 points. Okay, multiplied by the angular acceleration. So angular acceleration of which link? Link AB. Angular acceleration of link AB. By this formula I will find the magnitude. What about the direction? Direction of the tangential component is perpendicular to centripetal component. It is already, we are knowing it. Okay, so I have to draw a perpendicular through point X. So I can draw it in left side or in right side like this. Okay, but the this, what will be the true direction? The direction in which this velocity is there, velocity of B with respect to A. So as it is going, this velocity is going upward, so I will draw a upward like this. Remember that this line which I am drawing is perpendicular to the radial component. Okay, and many times it is not known to draw this line on which direction. Okay, so what we do, we just draw the line, and later on when some other line comes, so we find the point at the intersection point. Okay, so when we will be solving the numerical, you will realize that, so a dash x I have drawn, then from x I have to draw b dash, so x to b dash I have drawn like this. Okay, it is centripetal component a dash x, x b dash is the tangential component. If you add these two, if you add these two like this vectorially like this, then this vector a dash b dash, it will represent the total acceleration. It will represent the total acceleration of point B with respect to point A. So you can see that total acceleration is the vector addition of centripetal component and your tangential component. So in this way you go on solving for every other link and you will complete the acceleration polygon. Okay, so the difference between velocity polygon and acceleration polygon is that velocity vector, for velocity vector you draw a single line. Okay, but for the acceleration vector you have to draw these two lines, for because the acceleration has two components. Okay, so you need to remember all these things in order to solve the problems on acceleration. Okay, so you note it down and let us go for the next problem. Okay, let me know if you are done.
Done, sir.
Okay. So let us now solve an numerical on it, the acceleration analysis. All of you, please note it down, this numerical. So thing is that before doing the acceleration analysis, you need to do the velocity analysis first. Okay, then you you will go for the acceleration analysis. Okay, so while we will solve this numerical, we will cover one more problem on velocity. लास्ट टाइम हमने वेलोसिटी एनालिसिस देखा था. बाय सेम मेथड वी विल डू फर्स्ट द वेलोसिटी एनालिसिस, then we will go for the acceleration analysis. Okay, so you note it down first. So this is the slider crank mechanism. Slide. This is your slider. This is the crank OB. and say slider point is A. So crank length is given 150 mm. OB कितना दिया है आपको 150 mm. OB is the crank and AB is the connecting rod. Okay, and point A is the slider point. It will slide, it will reciprocate in horizontal path like this, and crank will rotate. Okay, so crank is rotating at constant speed of 300 rpm. Okay, so what is given to you is the NOB, and that is rpm of the crank. It is given 300 rpm. Then length OB is given to you 150 mm, and the connecting rod is 600 mm long. So connecting rod is AB. It is 600 mm long. You have to find linear velocity and acceleration of the slider. Means point A का आपको velocity find out करना है. Velocity of point A, as well as what you have to find out, acceleration of point A. Acceleration of point A. These two factors you have to find. And angular velocity and angular acceleration of the connecting rod means आपको find out करना है omega of AB, omega of AB. Then you have to find out the angular acceleration also, means alpha of the connecting rod. These four factors you have to find. Crank is at an angle of 45 degree from inner dead center position. Okay, so when OB and AB are in a straight line, okay, such that B is in between O and A point, that position is called as inner dead center. Here the inner dead center position of the crank, IDC. Okay, so this angle is 45 degree. It is given that the angle of crank from the IDC position is 45 degree. So this angle is given to you. It is 45 degree. Correct. Now you have to solve this problem. So you can see that in this problem you have to find out velocity also, as well as the angular velocity. Means it is same velocities, and also you have to find the acceleration. Now if you go to find out this with the help of ICR method, in ICR method you get only the velocities, not the acceleration. Okay, so from here you will know that this problem should be solved using the relative acceleration method. Okay, so again in this problem also, very first step after writing the given data is to draw the space diagram. This diagram you have to draw with the help of with its dimensions. With scale you have to draw it. Okay, so what scale you will select? For example, OB is given 150 mm and AB is given 600 mm. So if you take scale as 1:10, then the crank length will be only 15 mm, very less. Okay, so instead of taking scale as a scale factor of 10, you take the scale factor of 5. That is, you take K as 5. Okay. If you take k equal to 5, then length OB will be how much? 150 divided by 5 means 30. Okay. And length AB will be 600 divided by 5.